My name is Hawa.
And I'm David Stein, and we're here to talk about our ECP2 project for ECE 285 in the spring 2015 semester.
So we came with the idea. David came with an idea to design a car that trace the light. So we have the car here that has the two photoresistors with two op-amps, and we have also the two transistors that power the motors for the car.
Mm-hmm. Our initial proposal for this circuit was to build a vehicle with a set of 4 photoresistors positioned in opposite corners of the vehicle, where each pair of photoresistors would run through a comparing op-amp to power a wheel in either a forward or reverse direction, depending on whether the laser was at the forward or rear of the vehicle. The first problem that we ran into was that the design of the motors and axles and gears was simply too precise for this project. We couldn't build it from scratch. So instead we acquired a set of remote controlled vehicles and simply took the motors and wheel assembly off of that. The next problem that we ran into was that the photoresistors were not sufficiently sensitive for the laser. So we built a visor for all the photoresistors with a red gel filter to be selected for the red laser pointer. This wasn't sensitive enough, so the next step that we took was to put some dark tint film over the red gel filter on each of the visors. This still wasn't sensitive enough, so the next step was to replace the idea of a laser pointer with just a very bright flashlight shining right at the photoresistors. This worked well for sensitivity, but these photoresistors that we were using were very selective for the angle. They could only sense it if the flashlight was pointing directly at it. So we started using different photoresistors then that were more omnidirectional, and those worked fine. The next problem that we encountered was that the battery doesn't have negative voltage. It only provides a range of positive 3 volts to 0. So the op-amps couldn't drive the wheels in a rear direction. So instead, the first solution that we tried was to try running each of the photoresistors through a voltage follower and then into each side of the motor to create a voltage difference over it in either direction. Unfortunately, this didn't work because there was no ground connection, so the motors didn't go anywhere. The next step that we tried was to create a transistor bridge that would allow the current to flow in either direction over the motor to power it in either a forward or reverse direction based on the output of some comparator op-amps. The problem that we ran into here was that even though this worked, the transistors were too sensitive and they would burn out at the voltage and current that we were providing through the motors. We burned out a lot of transistors before we decided this wouldn't work. So we decided to scale a project back to only have 2 photoresistors, each one running through a differencing op-amp and powering a wheel in just a forward direction. This worked okay, but the problem was that the motors wouldn't run from the output of the op-amps. There simply wasn't enough current that's being provided by these simple op-amps. They're not designed to drive a load. So the solution was to take the output of the op-amps and then to feed them into a transistor in a current amplifying mode with a common collector. And this worked perfectly fine. The wheels would then get enough power to be driven. Unfortunately, they didn't get enough power to propel the vehicle that we built. The vehicle was just too heavy. There are some potential solutions to this, such as reducing the weight by making the board lighter or smaller. We could also boost the voltage by using a larger voltage source, or we could reduce the wheel friction to enable the power to lose less power to friction. Power itself. So what we actually have, though, is this solution. And this is our car. And when we put in the battery, we can see that if we power it over here, we get this wheel running. We power it over here, we get these wheels running. So this is at least a proof of concept. And it works okay. So just to show off exactly what the circuit is like. So what we have is this very simple circuit where we have these 2 photoresistors running into the op-amps in a differencing configuration and then running down to these transistors. And then finally the output is running out to motors that are in the back. And this is our very fancy soldering job. So this is our ECP2 project. So thank you for listening.
Thank you.